So last class we were described, like first of all I will repeat like three type of statistics: descriptive, predictive, and prescriptive. So what happened means like past when we analyze, then it is called descriptive. Then we predict into future what is going to happen, then it is called predictive. And how can we make it happen? Means when we tell business that boss, this is what happened in your past, this is what is going to happen. But if you do these changes one, two, three, if you do these changes in your business, then your revenue may improve by X percentage, or your efficiency can improve by X percentage. Okay. So like that, we can have kind of to see the three main branches of statistics. So here, couple of more you can say. So like descriptive like means like which describes the past data. Descriptive statistics means which describes the past data. Okay. So like if you know that normal distribution, we have taken couple of classes on normal distribution. So if you see the central line, like the normal distribution curve, recall normal distribution curve, and the central line is the peak, right? It represents the mean, median, and mode. So in normal distribution, mean is equal to mode is equal to median, right? So central line represents all the three. So mean, median, and mode are called central tendencies of data. So like we are talking about the center point of the data. When we talk about mean, median, and mode, then we talk about center data, point of the data. So now I have a question. When we'll use mode, guys? This we have discussed a couple of times. So when we'll use mode actually? Why we should use mode? When we have mean and median, why should we use mode, guys? Anybody idea? Anuparki, why we use mode? First of all, what is mode, and why we should use mode actually? Why it is required? Tell me, guys. Anybody? Anup?
It's a frequency of occurrence.
Yes, very nice. Correctly
Frequently
answered.
occurring number.
Yes, frequently of occurrence is mode. Correctly replied. Not only frequency of occurrence, maximum frequency is called mode. Frequency may be for every entry, but the maximum frequency we take as mode. So now why we use it? Why when we have mean and median, why mode is required? Why it is required at all? I'm asking why to study it, why to give importance to it. What is the reason? Okay, guys. Yeah, tell me. Go ahead.
Yeah, so it's indicate the maximum possibility of occurrence, so we can predict based on that.
Correct. That is one of the reason actually. But we have more compelling reason of using. That is what you told is right. But that is somewhat secondary reason you told. I want the primary reason meant to why to use mode. Primary reason I want why to use mode. Without that, where you cannot use mean, you cannot use median. You cannot use median in those cases. So why we should use mode? Tell me. There is one case I'll tell you in which you cannot use mean, you cannot use median.
It basically helps us to understand the data distribution also, right?
That is okay, but still it is not compelling reason. I'll tell you one compelling reason. When I'll tell, then you will tell yes, that is the reason. You know about it. Now tell me, guys, I have a column called cities of India, like column. Column name is cities. Bombay is repeated 2 times, Delhi is repeated 3 times, and Bangalore is repeated 2 times. So what is mode in this data? Bombay is repeated 2 times, Delhi is repeated 3 times, and Bangalore is also repeated 2 times. So what is the value of mode, guys, in this data?
Bombay.
Mod is 3.
Why Bombay?
Delhi, I mean.
Mod is 3, right?
3 times repeating Bombay.
Yeah, 3 times. No, I said 3 times. Delhi repeating 3 times, right? Bombay 2 times, Delhi 3 times, and Bangalore 2 times. So Delhi is
Delhi.
repeating 3 times, so Delhi is more. Do you agree for that?
Yes.
Okay, now in this case, I have only like how many total data entries I have? Two, 2 times Bombay, 3 times Delhi, 5 plus 2 times Bangalore. Only 7 entries I have for that column. Cities. Can I find mean and median, guys, in this case? Can I find mean of this data? Can I find mean of Delhi, Bombay, and Bangalore?
No.
No, right? In such a case, where the data is not numeric, in such a case, there is only one parameter is that you can use is that mean. Like mode only is the thing which you can use because median also has no meaning and mean also has no meaning. So you have to use mode. Okay, now you got it, guys. So now, so mean, median, and mode are central tendencies because they indicate towards the in whatever is the data distribution. So it indicate towards the center. So mean, median, and mode are central tendencies. Now, suppose data is spread across. So like I have entries 2, 3, 5, 2, 3, 4, 5, 6. Remember 2, 3, 4, 5, 6. What is minimum value in this?
Two,
What is minimum? What is maximum?
6,
6.
What is the range?
2 to 6,
What is the range?
2, 3, 4, 6,
No, no. Range is maximum minus minimum.
4.
4. That is range. And standard deviation and variance I already showed you in one of the numerical examples. So it is here given here. See link, it is given here. That link you can open and then you can see how to calculate standard deviation and variance. So we like couple of times we have discussed, so I'll not repeat. So these are the one is central tendency and one is dispersion. Like dispersion means how spread the data is, minimum and maximum. Sorry guys, wait. Sorry about that. So one is central tendency, mean, median, mode, and another is dispersion. So dispersion is maximum minus minimum, that is range. Dispersion is measured by how spread the numbers are. It is measured by standard deviation. It is measured by variance. So variance and standard deviation we had discussed last time, and I had explained you why 2 units are required: variance and standard deviation. So standard deviation is nothing but square root of variance. So I explained you why both are required. Okay. So now, if it is not clear, either you ask me a question or then you have to give me a second, and I need to take this call. Just give me a Sorry, guys. So I had to that call was important. So central tendency is mean, median, and mode, and dispersion. Dispersion means spread of data. So range is maximum minus minimum. That is one measure of dispersion. And the standard deviation and variance is another measure of dispersion. And then I told you two more things which I will teach you, like which is it is written in 5 and 6, little different color, like brown color, like little gray color. So kurtosis and skewness. That's what we stopped at. And then I told I'll tell you in next class. But today's class also I'm not covering this kurtosis and skewness. We'll cover these in some other lecture in next future because they will come in. They are covered in say more than 10-15 slide. I have denoted to kurtosis and skewness. So one of some other lecture, couple of lectures later, we'll discuss them in detail. So right now, keep this question in mind that there are two more things we have to discuss: kurtosis and skewness. Okay, so today there are only 4-5 PPTs like I planned today, which are pending for this, which are pending for this particular like to complete this slide deck. Only 4-5 PPTs are pending. So today that's what we'll complete. Okay. So now it is one more view of descriptive statistics. So see, descriptive statistics, I told you mean, median, and mode. See here. First of all, descriptive statistics here is on the top. It is divided into two branches. One left hand side is measure of central tendency, and right is a matter of dispersion. You understand both of them. What is central tendency and what is dispersion? So in central tendency, we have mean, median, mode. So we know mean, median, and mode. So here two more things are given: harmonic mean and geometric mean. So they are also taken as like measures of central tendency. And I'm not repeating this harmonic mean and geometric mean because I would like you to write down right now what is harmonic mean, what is geometric mean. All of this has been studied in 11th class if you have done your 11th class mathematics in mathematics and science. And all you have studied harmonic mean also and you have studied geometric mean also. So I want you to note it down and search it Google. It will to revise your memory. Then measure of dispersion range we have discussed, maximum minus minimum, minimum deviation we know, standard deviation, and quartile. So quartile, now I am going to explain you what is quartile. Okay, quartile means how many of you guys have given GATE exam? Guys, how many of you have given GATE exam? Yeah, one guy has dropped. Yeah, one guy has dropped. Karthik, so one guy has dropped already. Who has dropped? Amit Bhai.
Yes,
Anup has
sir.
dropped. Anup has dropped. Okay. So have you any of you given JE and like not JE? How many of you gave JE guys? Or GATE? Have you heard two terms like who has given GATE or JE guys?
Sir, I have given greater J.
I have given GATE and
Okay,
GE both.
okay, GATE and JE. So like I will ask to Gajendra because he has given both the exams. So you got your marks in percentile, right?
Yes.
And there is one term like your every exam, any exam which you have given 11, 12, 10th, you got your marks in percentage,
Yes.
70%, 80%. So there are two terms here. One is percentage and one is percentile.
Yes.
For an ordinary man from arts background and all, they treat both as same, but they are not the same. So Gajendra, what do you understand? Like you have given both JE and GATE, and you have got a score in percentile. So, but what does percentile mean for you? Percentage, everybody understands. Suppose out of 100, I got 70 marks, so 70 percentage I got. If I get 72 marks, I got 72% marks. It is out of 100. Everybody understand percentage. We need not tell. We give some like discount is given as 8%. Means in every 100 rupees, 8 rupees is minus. That's what everybody understands, right? So now tell me, what do you understand by percentile? guys. Gajendra or Karthik, you have given, you have got once your score in percentile. So tell me what is the difference between percentage and percentile?
Yeah.
Yeah, anyone, if Amit wants to answer or Jignesh.
Percentage is related to marks, it's
Okay.
100 out of how much marks we receive, 70-80%. A percentage means out of people, how many people qualify, like out of 1 lakh people apply, and in that your ranking is that like this.
No, you are little bit closer, but you are not right.
Yeah,
Anybody wants to
percentile
improve it?
is mean that maximum numbers we consider as a percentile 99.99 or 100.
100, we consider it as 100 percentile.
Yeah, and then respective we are calculating based on that as a benchmark.
Superb, Jignesh, superb. Got it. Very nice. You are rightly defined. See, now I'll tell you, for everybody else, percentage now everybody knows. I need not explain because with that, that's what we learn in third, fourth standard or fifth standard. I need not tell you. Percentile means suppose there are 10 guys. 10 guys and in the exam only 10 guys. For example, only 10 guys appeared. And exam maximum score was 100. So now in percentile, what we got? The topper of the exam got only 85 marks. The topper of the exam got only 85 marks. Okay. So that 85 will consider as 100 percentile. Maximum mark we take as 100 percentile. And relative to that, we calculate the percentage. So now second guy, out only 10 guys were sitting, right? 10 guys only were sitting. So second guy suppose got 82 marks. So how much will be his percentile, Jignesh?
Second guy got how much marks? Sorry.
82 only.
Okay.
And first guy got 85. So his percentile is 100. There are only 10 guys in the exam. And second guy got 82 percentage, 82 mark. So how much will be his percentile guys? Now, Jignesh, according to your definition, you should be able to tell how much percentile second guy got.
Yeah, we can say an approx 96.
Yeah, 96.4.
Not correct, Jignesh, not correct. Anup bhai, can you tell? Anup Parki, are you there? Topper got 85, so his percentile is 100. Second guy got 82 marks. So how much will be his percentile, Mr. Anup? Anup? How much will be second guy's percentile? Guys, it is relative ranking. It is relative ranking. Okay. So now
99.
No. His percentile will be 90. Yeah. His percentile will be 90.
Yeah.
Because only 10 guys are there in the exam.
Yes,
then his position is 10% below than like one is, if his position is ninth, like suppose topper got first position. Now second position is one position below that, na? One position below. So now one is 10%, right? Because there are only 10 people in the exam. There are only 10 people. So if his position is second, that means he is 10% below the first one. Got it, guys? There are only 10 people in the exam. So each mark, each rank is 10%. So first one is 100%. Second one will be 90%. Third one will be 80%. Seventh one will be 70%. Like the third one will be 80. Fourth one will be 70. Like that it will reduce 10 marks, because there are only 10 guys in the exam. And if one rank you are below, means you are 10% below the first one. Got it, guys? Is it understood, guys? Jignesh?
Yes, sir. So last one having the like
10%.
10%.
0 percentile.
Okay.
0 percentile. The guy who got ninth position will have 10 percentile.
Okay.
Last one will have 0 percentile. Now tell me, now I have 100 people in the exam. 100 people in the exam. And topper got 100 people in the exam now. Topper got 85 again. So his the percentile will be 100. And second topper again got now 82 only. So how much
99.
will be his percentile?
99.
Yes, 99. Correct. Because if there are 100 students in if there are 100 total students in the exam, each rank is 1%. Each rank is 1%. Now you got, guys. So it is percentile is nothing but the relative rank out from the top. Relative rank from the top. Okay. So now there is a very nice plot here in front of you, which tells you the dispersion against this. This is box plot. This plot is called box plot. It is piston like. You see that piston like, no? There are two stopper at the end, and in between there is a line, and there is a box here, and then there are two lines on both the ends. This is called box plot. This plot is called. Whenever you see like this, you should understand it is a box plot. So what does it indicate? Anybody wants to take a guess? How to read it actually? How to read this one? How to read this one, guys? If you don't know minimum and maximum, can you read here? So
Yes.
the stopper, the first stopper will be minimum, represent minimum marks, minimum number. So then if suppose you have 2, 4, 5, 6, 2, 4, 5, 6. So 2 will be represented by minimum and 6 represented by maximum. So 2, 4, 5, 6, 7. I want to take 7, 5 numbers. 2, 4, 5, 6, and 7. So minimum will be 2 and maximum will be 7. Now Q2 means it will represent midpoint. It will represent 50 percentile. 50 percentile it will represent. So 50 percentile means Q2 will represent which number?
3.5.
No. You say 5 numbers we have, na? 2, 3, 4, 2, 3, 4, 5, 6, 7. How
Okay.
many numbers we do?
You said 7, so that's why 7 divided by 2.
No.
So
Now let me revise my problem. I have 5 numbers. 2, 3, 4, 5, 6. 7 is not there. 2, 3, 4, 5, 6. Only 5 numbers. So minimum will be 2, maximum will be 6. Everybody understands. Now midpoint will be what? Q2. 50 percentile will be what?
4.
4, right? 2, 3, 4, 5, 6. Yeah. So midpoint, like, it is 50 percentile. Because 50% are 50% numbers are above it and 50% number are below it. 2 are above it, 2 are below it. Right? So it is 50 percentile. Now in this case, what is Q1 and Q3? That is the main point. What is Q1 and Q3?
Q1 is a 3 and Q1 is a 3 and Q3 is a 5.
Yeah. So Q1 will represent 25th percentile. 25th percentile. And Q3 will represent 75th percentile. So minimum, then 25th percentile, then 50th percentile, then 75th means Q3 means 75th, and maximum will be 100 percentile. So like we have 5 numbers, no? So 1, 2, 3, 4, 5. So each number, each rank, like each rank is representing 20%. 20%, right? Each number is representing 20%. So like Q1 will not be exactly yeah, your whatever you said, it will be little here and there below close. So 2, 3. So it will be around nearby 3 point something, and Q3 will be 4, 5. So it will be 5 point something nearby 5, but exactly it will not be there because each number is represented. 5, there are only 5 numbers. So each number is representing 20%. So now here we want Q1 means we want 25%. So each number is 20%. Suppose if I ask you 20%, then Q1 will be 2 and 3. So Q1 will be 3. Because if I ask you 20% means Q3 will be your 20%. 4 will be your 50%. And Q3 will be 80%. Like 2, 3, 4, 5. So 5 will be 80%. So 2 will be your 25%, and 5 will be your 80%. But we are not interested in 20 and 80. We are interested in 25 and 75. 25 and 75. So they will be nearby that. So 25 will be nearby to 20%, and 20 20 like 75 will be nearby to 75%, right? Like nice, 75 will be nearby to 80%, and so it will be nearby to 5. Q3 will be nearby to 5, and Q1 will be nearby to 3. Got it, guys? Ideally 2, 3, 4, 5, 6. So 3 will represent 80 percentile, 4 will represent 50 percentile, 5 will represent 80 percentile. So, but we are not interested in 20 and 80. We are interested in 25 and 25 and 25 and so like 25. So suppose there are 100 numbers. Suppose there are 100 numbers, 1 to 100. So let us take a simple case. There are 100 numbers, 1 to 100 in a column. 100 entries are there. So minimum will be 1, maximum will be 100. Now here 21 will be like what will be Q1, Q2 and Q3, guys? 1 to 100 numbers. What will be Q1, Q2 and Q3?
Q1 will be 25,
Yes.
Q3 will be 75,
Yes.
and Q2
Now
will be
Q3, Q2 how much?
50.
Yes, very nice.
Maybe
Correctly answered.
25, Q2 is 50, Q3 75.
Yeah, so Q1 25, Q2 50, and Q3 75. Now you got you got how to read it, and you got the percent of quartile. So this Q1, Q2, and Q3 is called quartile. Quartile means quarter of a rupee, 1/4 of a rupee, 25%. So first quartile is 25%, second quartile is 50%, and third quartile is 75%. So increment by 25%. Got it? First is 25, add 25 to it, Q2 is 50, add 25 to it, 75. So 25, 50, and so they are called Q1, Q3, Q1, Q2, and Q3 are called quartiles. So they represent value. Q1 means 25 percentile, Q2 means 50 percentile, and Q3 means 75 percentile. Got it, guys? How to read it? Then minimum and maximum are the extreme limits. Now tell me something, guys. If something is like whatever stopper you see at the both the ends, if something is on the left hand side of stopper, what you call it? If something is there on the left hand side of the quarter, like the left hand side to stopper you see, some numbers are below it. So what you will call it, guys?
0.
No. And something is there on the right hand side of maximum. What you will call it? So they are called outliers, guys. So they are called outliers. So whatever is below minimum, below stopper, it is called they will be represented by dots. So dots will be there. So these dots will be outlier. Something will be right hand side of maximum. So they are maximum outlier. And left hand side of minimum, they are minimum outliers. So they are called outliers. So this particular box plot, in one shot, in one line of code, you can make with the help of Python. If you have a data code, if you have data column with some entries, with one line of Python, you can make this one line of Python code, we can make this box plot. And why we see box plot? Because we want to see the dispersion. We want to first of all see how many outliers are there or not. So suppose some dots are there on the left hand side of minimum, means minimum side some outliers are there. If there are some dot on the right hand side of maximum, means maximum side outliers are there. Then what it will tell you extra information? It will tell you box minimum, what is maximum, what is 25 quartile, what is Q2 50 quartile, 75 quartile. So it gives you very nice dispersion, like it gives the spread, right? Spread. What is minimum, what is maximum, what is 25 quartile, what is 50 quartile, what is 75 quartile. So this gives you the idea of spread. And what is sitting at 25 quartile, what is sitting at mean means 50 quartile, what is sitting at 75 quartile. It will tell you that idea. Plus it will tell you whether outliers are there or not. If left of the minimum outliers are there, means they are minimum outliers. Dots are there, they are minimum outliers. If some dots are there on the right of maximum, they are outside outlier. So like if we are working with linear regression and logistic regression, they are called linear models. Linear regression and logistic regression. So we are not studying in this course, but if you learn machine learning and all, you will study linear and logistic regression. So in that case, you need to remove that outliers, because otherwise your algorithm will not work. Whatever result you get will not be reliable if you don't remove the outliers. But if you are working with decision tree model like your random forest or XGBoost or decision tree, then you need not remove outliers because it can handle outliers very effectively. With outliers also it works correctly. Okay, guys. So then next is one more type of statistics I have introducing here. One is inferential statistics. So inferential means you have population, lot of population. You take a sample, you study the sample, and based on whatever inferences you get on sample, you apply it to population. This we have discussed number of times, right, guys? So this kind of inferences when we do, like when we study sample and draw inferences about the population. So this kind of statistics is called inferential statistics, because studying the sample is helping us to find inferences about the population. This we have studied a lot of times, right? So what are the measures? Like there are estimations, hypothesis testing, and so these are the techniques for inferential statistics. So for hypothesis testing, there will be a complete session will be there. So like we'll have, so we are not discussing right now what is hypothesis testing. So we'll have a complete 1 or 2 sessions on hypothesis testing going forward. So these are the inferential statistics I explained you. Like you study the sample, and whatever sample characteristics you get, that you based on that you try to guess how the population will be, how the population will be. So that kind of inference, based on studying the sample, you draw inferences about the population. So that is inferential statistics. So main tools are like your hypothesis testing, confidence interval, and regression analysis. So all the three we'll study in future classes. So I'm not taking you to more details of inferential statistics, but at this stage, you should understand what is descriptive statistics. So descriptive statistics is nothing but we are studying about whatever data we have, we are studying. So all these measures when we see like mean, median, mode, harmonic mean, geometric mean, so they are measures of central tendency. And when we want to see dispersion, range, mean, deviation, quartile, so this also box plot also is a tool for descriptive statistics. So we know what is descriptive, what is inferential. So at this point, you should know only this difference. What is the difference between statistics, inferential statistics, and descriptive statistics? And what are the tools? So like all the like tools are, you are familiar with descriptive tools already, you are familiar now. Boxplot also is a tool for, it's a graphical tool for descriptive statistics. Okay, because we are studying the spread. Okay, so it helps us to understand spread, like what is there in minimum, what is there at 25 percentile, what is there at 50 percentile, what is there at 75 percentile. So it gives about the idea about the data, like what kind of data we have. Maximum, then it tells you, right, whether it has lower side outliers or outliers or higher side outliers, whether outliers are there or not. You can find out with the help of box plot. Now the tools for inferential statistics are hypothesis testing, confidence intervals, and regression analysis. So they are tools for inferential statistics. I told you on each of these tools we will have more than one class. So I'm taking you in great detail. We'll study all the techniques, like what is regression, what is confidence interval, what is hypothesis testing. So I'm not wasting time right now and giving you introduction, because when we study that classes, a couple of classes later, so that time it will be clear to you. Okay. So inferential statistics concept, now you study like whatever you studied in probability, like probability we have devoted 15 classes, right? 15 hours of teaching was for probability distribution. So see, whatever you studied in probability, all of it comes under inferential statistics. See, we studied basic probability laws, conditional probability we studied, probability distribution, PMF, PDF we studied so many times, normal distribution we took 2 classes, standard deviation, and then Z score. I explained you Z score also in one of the class. So all these concepts we have studied in 15 classes, guys. Not much, not less. 15 hours of teaching we have done for all these concepts. So all the probability concepts that we learned in last 15 classes, so they are related to inferential statistics. They come under inferential statistics. Then there are some like these concepts also we see: sample mean, population mean, central limit theorem. I taught you central limit theorem also in second class. I think we did first year. Confidence interval I have not taught you so far. Confidence interval we will do in next classes. Interpretation of how the what is the significance, what is the interpretation of confidence interval, that we'll see in the next classes. Then point estimate and interval estimate, that also I have not taught you. But till 4, 1, 2, 3, 4 we have already studied. What is sample mean, what is population mean, what is statistical inference, what is central limit theorem. Central limit theorem, it is told, it is one of the most important theorems in statistics. And if you call yourself as a data scientist, you must know what is central limit theorem. Otherwise, you should not call yourself as a data scientist. Okay. So it is that important. So up to 4 we have studied. 5, 6, 7, and 8 we need to like study. We will study in next classes. And then there are these concepts are given in detail in the blue color on the right hand side. Hypothesis testing, null hypothesis, alternate hypothesis, p-value, t-test, type 1, type 2 error, chi-square test, chi-square test of independence, chi-square goodness test. All this will be topic of next 5, 6 classes. This is all we are going to study in detail. So I'm not explaining, but these are the like kind of things which come under inferential statistics. And guys, mind it, 15 classes we have covered the concept of probability. So all that, whatever PMF, PDF, whatever we covered in 15 classes, everything comes under inferential statistics. Okay, guys. So now predictive statistics, guys, anybody wants to give an example? Predictive statistics. So many times we have discussed. Anybody wants to give any example? Guys,
So
any example for wrong answer, there is no penalty. Don't worry.
for weather, I mean, the weather, the temperature of Ahmedabad will be between 12 to
Yeah,
15.
next 7 days temperature.
Yeah.
Or next 7 days, how much rain will be there in rainy season, right? So those kind of, that is called predictive analysis. That is predictions about weather. But here there is one definitive example, how we do predictive analysis. We see historical data, we study the historical data, and based on that historical data, we apply some statistical model, and based on that, we do some predictions. Then suppose stock price. So last 52 weeks, stock was price. I will study every week what was the stock price. So based on that, I'll apply some statistical model and try to predict stock price for next 5 weeks. But generally, guys, nobody can predict stock price correctly. If you can predict stock price, everybody will be a millionaire. But nobody has perfectly successful at predicting stock prices. You can predict many more things, but not stock prices. It is very uncertain, and no mathematical model. You can go near to it. You can apply some statistical model, do some stock prediction, price prediction, plus you add it with your experience and your business knowledge. Then only you can be successful. If purely based on model, if you do your investment or if you buy or sell, you will be bankrupt. So statistical model, no statistical model in the world has still now fully able to correctly predict, correctly able to predict stock prices. But still you can take some help. 30%, 20%, 30%, 40% accuracy is there. So those kind of models are available. Okay. So we if we know stock prices, next 5 days or next 15 days, how the stock is going to behave, then I can take my investment decision whether I have to buy the more stock or I have to sell my existing stock. Those kind of things can be done. But stock prediction is a wrong example for predictive analysis because those kind of predictions are not accurate. So accurate things, what you can do, like you have 1 year data for Amazon.com. 1 year data you have every day, how many customers visited, what time customers visited Amazon.com. You have that data for every hour for past 52 weeks. Every hour wise data you have. This hour, this many came, 2 o'clock, this many came, 4 o'clock, this many came, 5 p.m., this many came. Like that, you data you have for last 52 weeks. Based on that, you can apply, say, some regression or some random forest technique or some XGBoost technique and predict that next 3 months, what is the traffic, what is the traffic going to look like for Amazon for next 3 months or full next year. What is the traffic going to look like? I have 3 years of, suppose I have 3 years of traffic data for Amazon, hourly traffic data for Amazon. So studying that data, I can apply some techniques which I am naming here, linear regression. Linear regression will not work here. So either you have to apply neural network, XGBoost or random forest, non-linear technique. You can predict like how much, based on 3 years data, you can predict next year how much Amazon is, how much, what kind of traffic Amazon can expect every hour, that you can predict. What is the advantage? If you can predict the traffic for next 1 year, Amazon can plan resources like how many people they need, how many contract staff they need, how many servers they need to keep, how many, how much memory it will need, how much computing capacity it needs, how many servers they need to keep, how much staff they need, how much this is the computing aspect. Then based on that, if that traffic pattern for next week is known, Amazon can stock goods, various kind of goods. They can plan their goods, like what kind of goods will sell, so they can stock them. So those kind of planning, business planning is possible. So that is a real example of predictive analysis. I won't say stock prediction is not a real example because their accuracy is very, very less. But in case of American example, which I discussed, accuracy can be as high as 80% or more. Accuracy can be as high as 80% or more. So that is the real example of stock prediction, like the predictive analytics. Okay. So by predicting the traffic, Amazon can plan the business properly, computing capacity, they can stock goods properly. So it will improve their operational efficiency. And suppose some like Christmas time, something is selling more. So that thing can be predicted. Like COVID time, predictions were there that people are working from home. So a lot of computing machines like laptop, desktop will be sold more. So like many companies lost in that case because they went out of stock in COVID. COVID period, if you went to buy laptops, most of the companies were out of stock. So they lost this much sale, right? If they had stock, they could have sold. They could have made revenue. They could have made dollars. But most of the companies, like I went couple of times to buy my Apple machine for my brother, my son. But most of the time, like 2 years, most of the time, this Dell, Lenovo, Apple, everybody was out of stock. So they couldn't keep like stock. Sale was so high, their manufacturing capacities were limited, so they couldn't fulfill the demand. So if they could have predicted like 1 year before that this kind of demand is going to come, then they could have increased their production capacity, stocking capacity. But there was no prediction because COVID came suddenly. Nobody could expect that this kind of demand will be there for notebook computers or desktop computers. So everybody lost a lot of sales in that period because no predictions could be done. COVID came suddenly, like, so no planning could be done. So that is the example of predictive analysis. And then some examples are given here, like weather forecasts, like Amit already told. Then creating video games. So guys, have you any idea like how predictive analytics is used in video games? Are you very nice, very gamer? Any of you is a gamer, guys?
So just a wild guess I can do. So
Yeah.
let's say if I'm, I mean, most of the users using the video game, and I mean, based on that, it can be predicted that, I mean, where they are stuck or what algorithm mostly they are using, and based on that, the new features can be provided.
Yes, yes, very right. See, the character, the main character, his moves can be predicted in advance using algorithm. So it is used in gaming. Then mobile messaging, you know that you keep typing now in your text messaging. When you do, you type one thing. Couple of words are already given to you as suggestion. So that is predictive modeling in natural language processing (NLP). So a couple of words are already given to you, right? So you can choose and you can quickly do something. You need not type that. So that is the predictive modeling in your text messaging. Then customer service. Customer service also you can predict like kind of demand and like what you plan. You can plan your business. Like you can like what kind of services will be required in what quantity. That things can be planned in advance if they you know the pattern. What the pattern is going to be there, how much demand will be there for customer service, which products service will be more in demand. So those kind of predictions can be done with method statistical models, and you can plan your business well in advance. Then investment portfolio development, everybody knows like stock prices. If I know five weeks, even if I have slight idea, I can plan my portfolio development, like should I buy the stock or sell the stock? Those kind of things can be done. So they are practical examples of predictive analytics. So I will there is one major difference between predictive and prescriptive. So predictive means like you know very well now what is predictive. You predict the future. But prescriptive means what steps you can take to improve your business. Prediction is say prediction is there that your prediction is says that next month's sale is going to be $10,000. For example, your predictive modeling says that 10,000 dollar going sale is going to there for some small business. $10,000 sale is going to be there. But as a business analyst, if you suggest that shopkeeper or that guy that if you stock these things or you keep 2 more hours open, or you if you little bit you do this kind of selling, or you if your product ratio like whatever you are stocking, if you change that mix, your sale can be $12,000. You are giving him prescription like a doctor. Doctor will give you prescription, na? If you do this exercise, if you eat like that, or if you take this medicine, your health will improve in so many days. Like that, we are giving prescription to the business. You take steps 1, 2, 3. Instead of $10,000, your sale will be $12,000. If you take these steps 1, 2, 3. So what is this step 1, 2, 3, which you are telling to the shopkeeper? They are nothing but prescriptive modeling, prescriptive analytics. You are telling him how to improve sales. That is prescription. And then this is the value chain. Like bottommost means first of all, very first thing you will do descriptive. It is in the bottom of pyramid. And then you will do predictive analytics, middle of the pyramid, and top of the pyramid, which at most value and which is most difficult. That is which comes in the last. First, you will do descriptive analytics, then you will do predictive analytics, and the last you will do prescriptive analytics. So prescriptive is most difficult, and it adds the most value. So what are the tools for descriptive? Dashboard and descriptive tools, mean man dashboard, whatever dashboard and box plots and all you make, that is descriptive. Predictive means you are doing some forecasting. So forecasting tool, regression, simulation, if you do, that is descriptive. And then prescriptive, so like your optimization whenever you do. So optimization whenever you do, like optimization algorithm you run, or you run heuristics. So I want to tell I have a couple of slides on heuristics. So I'll take it up. Heuristics. Heuristic means rule of thumb. I'm not doing any analysis, but based on my experience, rule of thumb I'm applying. So like this should be the profit percentage in my business. Based on experience or my gut feel, when I take, that is heuristics. So like this slide I will skip. So now heuristics I want to take up. Heuristics in business analytics refers to simplified rule of thumb methods of solving problems and making decision. Means I have to take a complex decision. No analysis can be done. Either time is short, data is not available, or proper subject matter expert is not available. So analysis is not somehow possible. So now when analysis is not possible, so based on some rule of thumb, I can take some business decision. So can anybody, guys, like all of you are from Gujarat, which is the land of business. So can you tell me one example of what is heuristics, use of heuristics in business? Can you give me any examples? Like, guys, all of you are from Gujarat. So like you should be able to give some example of how you are using your gut feel or rule of thumb in business. Any example, guys? Guys, any example?
Sir, I'm just trying, sir.
Yeah,
So,
try, no problem.
yeah,
There are
yeah.
no marks, negative marks. Don't
While
worry.
giving the promotion should not, or the discount amount should not exceed the, I mean, should not be less than our cost value of the product.
Okay. Okay. So like on your, I'll define it properly. Like you are a businessman and you are launching a new product in the market. Now promotion has to be done. New product is there in the market. So some promotion is required, marketing is required. So for that, if promotion is required, marketing is required, means rupees, dollars are required. Budget is required, marketing budget is required. So now marketing budget, how to decide marketing budget? There is no analysis. There is no scientific method available to like decide how much dollars or how many rupees I should allocate to marketing budget. There is no way. So now as a businessman, you are working in say Ahmedabad area and all. So you have some experience, old experience, like you are already a 55-year-old guy, a very seasoned businessman, and you have some experience that this kind of product can make me 1 crore rupees in a year. Like it can sell overall revenue I can get out of this product. Suppose it is some small kitchen product. So small kitchen product, whatever I sell, I can make up to 1 crore rupees, like $10 million a year. I can make. So based on my gut feel that it will sell $10 million, I can keep a percentage of it as a marketing budget. So maybe 1% or 2%. I can keep it as a marketing budget. So out of $10 million, I kept 2% as a marketing budget for full year. So how I have decided, I have not done any analysis. I have not done any scientific analysis. I have not applied any statistical model. I have not done any descriptive, prescriptive, or predictive analysis. So based on my gut feel, I decided that it may sell 1 crore rupees, $10 million. So let me keep say $10,000 for the year long marketing. Okay, so that's how, like based on decision, gut feel, rule of thumb, some business decisions are taken when analysis is not possible. It's a new product, so no data is available. How can you do data analysis? There is no data. There is no data means there is no statistics. There is no modeling because there is no data. Product is new. Market is also new. So how to decide then? So based on gut feel, rule of thumb, your experience, you decide that. So that is called heuristics. Okay. So like I want to tell you one example. Fraud detection, bank fraud detection. So what happens, like credit card fraud detection? So one example of prescriptive analytics. Prescriptive. Just read it here. Prescriptive analytics. So one example I want to give. Try to read the bullet points with me. For instance, you typically send $3,000 per month. Means you are on your credit card. your typical spend is 3,000, like average spend is 3,000 per month. You are having credit card for last 2-3 years, and bank knows that average this guy spends $3,000 per month, average spend. But this month, like in the month of January, there is a 30,000 charge on your credit card. Like some sale is going or something which is coming. So 30,000, one transaction is coming whose value is 30,000. Means you are going like some from a gold shop, or like you are sitting in Ahmedabad. It may come from some somebody is trying to use some very high value item from on your credit card. It is stolen, and in some country like Malaysia, or it is in US, or it is in Europe, somebody is trying to purchase some very costly item, maybe some very high ornaments. So $30,000 is the charge. Algorithm automatically analyze that this is not the pattern of your transaction data. 30,000 kind of credit card, 30,000 kind of transaction has never come on your credit card so far. So the statistical algorithm will put this 30,000 immediately as an anomaly. It's an anomaly. It is it is something like strange that this guy is spending only 3,000 and now this transaction is 30,000. It is strange, anomaly. Then it automatically the transaction will alert the bank officer that anomaly is this guy is having 30,000 transaction, whether we should allow or not. So that guy will see, this guy is having only $3,000 per month bill, and this transaction is $35, and then that too in foreign country. Immediately that bank guy will tell or they press some option in the software to block your card. So before transaction is approved by the bank, your card will be blocked. Your card will be blocked. So whatever fraud was going on your credit card, just one fraud detection algorithm, fraud detection statistical algorithm alerted the bank officer, and bank officer blocked your card, so that fraud was prevented. That is prescriptive analytics. What prescriptive action they took? They blocked your credit card. That is prescriptive action they took. Prescriptive action was blocking your credit card, right? So that's what it is taken. So it is the example of prescriptive analysis in action. So I think with this, my today's whatever I had planned. So I think I finished.